In this video, what we're going to take a look at is the distance formula and how the Pythagorean theorem relates to it. So we'll actually look at this problem in two different ways and kind of derive the distance formula from the Pythagorean theorem. So what we want to do in this problem is we want to find the distance between -2, -3, and 4, 1. Now we can't just count kind of diagonally because we don't know what the length of those are exactly. So what we're actually going to do is we're going to create a right triangle. And so now what we'll do is we can count vertically and we can count horizontally, because in the Cartesian coordinate system that's how it works. Each of those are 1 unit in this case. So here we go up 1, 1, 2, 3, 4. So we're going to go up 4 units, and I did that just by counting 1, 2, 3, 4 units. And then we're going to be going over 1, 2, 3, 4, 5, 6 units. So now we have a right triangle, and we're able to just say a squared plus b squared equals c squared, which is the Pythagorean theorem. So we can say 4 squared plus 6 squared equals c squared, which this is c here. It's our hypotenuse. So we say 4 squared is 16, and 6 squared is 36 equals c squared. When we add those together, we get 52 equals c squared. Take the square root of both sides, and the square root of 52 is approximately 7 21/100ths units. Okay, so a different way we can look at this, where we don't actually have to have the graph in front of us, is to have our 2 points. So -2, -3, and the point 4, 1. Now really all we're doing is finding the difference between our x points and the difference between our y points to find the lengths of those. So what we can do is, let's just label these our x sub 1, y sub 1, and x sub 2, y sub 2. All that does is say this is the x, this -2 is the x from the first set, the -3 is the y from the first set, the 4 is the x from the second set, and the 1 is the y from the second set. So if we find the difference between those, so I'm going to take 4 and subtract the -2, because difference means subtract, we get 6. So these are our x's. Our y's are 1 minus a -3, which is 4. So much like we found over here that our y change was 4, or our y distance was 4, and our x distance was 6, we then used the Pythagorean theorem and said that a squared plus b squared equals c squared, which was 6 squared plus 4 squared equals c squared, which is 36 plus 16 equals c squared, which is 52 c squared, square root both sides, square root of 52. So we see that if we find the difference between these and then we square them, that will give us our c squared. So what we can say then is x sub 2 minus x sub 1. If we square that, we can add that to our y sub 2 minus y sub 1. We square that. That gives us our hypotenuse squared. Now what we can do from here is we can take the square root of both sides. So then it becomes c equals, I'm just going to flip that around so you can see it a little bit easier. C equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And so this right here is the distance formula. No one ever showed me that the Pythagorean theorem and the distance formula connected, so I think that's a pretty cool thing. And so now from here we could just say, let's just plug our numbers into the distance formula. So we have our x sub 2 is 4 minus a -2 squared, plus our y sub 2, so 1 minus a -3 squared, which equals the square root of 4 plus 2 squared plus 1 plus 3 squared. I see a lot of people make a mistake when they subtract the negative. When subtracting a negative is the same as saying plus a positive. Okay, take the square root of 6 squared plus 4 squared, which equals the square root of 36 plus 16, which equals the square root of 52, which we said was approximately 7.21 units. So hopefully that helps you with the distance formula and how that connects to the Pythagorean theorem. Go ahead and like my video by clicking the thumbs up below. Thank you for watching.